Hi everyone, in this series we're going to talk about evidence in argumentative writing, so specifically what you can look for in order to make sure that the statistics and other resources mentioned in a piece that you're reading for your research make sense, that the evidence is valid. Statistics and numbers and facts and figures can seem very persuasive and solid, but can be very easily manipulated. So I will be giving you a lot of questions throughout these videos to ask yourself to keep in the back of your mind while you are reading. Over the course of this series, we'll talk about statistics, surveys, and sources, all in different videos, as well as different barriers to understanding argumentative writing, or the evidence specifically in argumentative writing. Our focus for this first video will just be statistics. Key question to keep in mind: what part of the findings are being shown? Let's get into more detail on that. So when you are presented with a statistic, a percentage, a fact, a figure, it can be very comforting. It can seem very solid that numbers are numbers and you can't argue with them. But there are still some ways to manipulate them. So you want to keep in mind whether or not all findings from the study or the survey are being shown. If so, how does that impact the reliability? And if not, why not? Sometimes it could just be that other parts of the findings truly aren't relevant to that piece. Maybe it's that, there's not space to go into detail for every part of the finding. But you have to ask yourself whether or not the publisher of the data has something to gain by publishing just a certain selection. So is there a part of the study or the survey that is more favorable than other parts, right? Does it benefit somebody to specifically show this one part of a study rather than showing the study in its entirety? You also want to examine what the standard of error is, or what the range is in the evidence shown. This can make a pretty big difference. Another common thing that comes up a lot with statistics is the use of averages, and you always want to ask yourself what type of average is being used, because it can change the numbers a lot. Right? So 3 types of averages. Again, we're not getting into such a statistical analysis here, just thinking about what you want to have in mind as you are doing your reading research. It could be the mean average, where you add all the values in a sample and divide it by the sample size. Could be the median, where you're just looking for the middle value within the sample. Or it could be the mode, the value that appears most frequently. Any of these could technically be called an average, but we usually assume when people say average that they're talking about the mean of something, right? So again, that's not to say that, everybody's a liar and you always have to triple check, but you do want to make sure that when you have in mind what type of average you're reading about, it lines up with what they created. Sometimes it doesn't really make a difference which average is used. That has to do more with things that have kind of a natural limitation or a natural range that occur. So for example, if you're talking about the average height or weight of a person, doesn't matter if you use mean, median, or mode, because you're not going to get that different of a number. There's kind of a normal range within which humans tend to fall. But it can make a big difference, especially when you're talking about things like income or property value, right? If we do the mean average of income in a company, then one person, maybe a CEO who makes a really, really high salary, can offset the income of people who maybe make a really low hourly wage at the same company, to make it seem like it's a very, very livable wage in the middle for everybody, right? Whereas if you look at the mode, that can give you something very different, where it tells you what most people are making, not taking into account any crazy exceptional CEO budgets. Same with property value, right? If you're talking about the average cost of housing in an area, using the mean will include any crazy multi-million-dollar homes, and inflate that a little bit more. Whereas if you're looking at the median or the mode, it'll be more like kind of, okay, what is the most common housing price you're looking to run into? So it can make a big difference in cases like that. When you are presented an average, you also want to ask yourself, what is this the average of? And how are the terms included in the sample defined? So for example, if they're talking about, oh, the average family makes this much, what does the study consider to be a family, right? Is it 2 people, 3 people, anybody who is related by blood, anybody who lives under the same roof, in the same household? How are those terms defined? You also always want to ask yourself, how relevant is the statistic being used? Is it really directly related to the topic at hand? Or is it what is sometimes called a semi-attached figure? So in How to Lie with Statistics, the author goes through a lot of examples of this, where it's very easy to have a number that seems very convincing attached to a topic, but when you take a closer look, you realize it really doesn't have anything to do with what's being proven. For example, in the book, he uses the case about, a juicer that claims to extract 26% more juice. Okay. And he points out that it doesn't actually say 26% more than what, right? It doesn't give you the alternative. It just says 26% more. That number seems comforting. Who doesn't want to buy the one that gives you a quarter more for what you're paying? But he points out that if this is 26% more than hand juicing, that could be the worst juicer on the market, right? Maybe it's just that this is more efficient than doing it by hand, and maybe every other juicer on the market gets 50% or 75% more juice. You also always want to ask yourself whether there is another explanation for the statistics. So is there another way to explain the number that you are being presented? For example, this one also comes up in How to Lie with Statistics. He mentions a study that says 4 times more fatalities occur on the highways at 7 p.m. than at 7 a.m. Right? So 4 times more fatalities occur on the highways at 7 p.m. than at 7 a.m. This is a great example where it could seem like, okay, well, driving at night is for sure more dangerous than driving in the morning, but you want to think about what other explanations are there for this, right? For example, more people are on the road at 7 p.m. than at 7 a.m. Maybe more people are ending a work day and are tired and not paying attention at 7 p.m. than at 7 a.m. So you want to kind of explore this idea of what else could make this statistic true. And that's it for this first video. In our second video, we will continue this series.